And once again, introduce today's topic. This is Study Physics and Physics of the Earth System in Germany subject webinar. Here are our guests. I will also introduce them separately. Before that, and before others are still joining, I want to mention about the organizer of the session. This is my German University, Germany's largest study program database. You can find there more than 24,000 study programs, not find, but all the programs that are offered by German universities are listed there. But you can find your study program because you can use lots of different filters, adjust them, combine them, and narrow down the search, and of course, select the one to which you want to apply. At the same time, we have something new. It is university search. I frequently get questions, can you advise which university could be better fit for me? And for this, now I directly give the link about search universities, and it really depends on different aspects. Where do you want to study, what type of city, what kind of university, and so on. So you have, again, all this information there. We have lots of articles. Those articles can be really broad, can be quite narrow, country-specific, topic-specific, and so on. In case you have broader questions, you can also check our articles. And the webinars, or my department, let's say like this, we have, as already said, more than 200 webinars per year. General and subject webinars. General webinars have the benefit that you will have there a broader topic, and we have a bit longer Q&A. But subject webinars have much more benefits because it's not only us from my German university, but guest speakers from German universities and also presenting their own program. So you have this chance to ask your question, clarify your doubts, and get to know the programs from wherever you are joining right now. This is our team. We are based in Hamburg, Germany, counseling in different languages, and also happy to share our experience of studying and living in Germany with you. I want to mention about counseling. Please don't take it as one-to-one counseling, because we do not do that. We think that the information we provide is enough so that you can start the application yourself. Now, as already mentioned, my part will not be that long. I would like to right away give the virtual mic to Professor Dr. Stefan Roos, who will be presenting Master of Science Physics programs.
Yes, as said, I will today present the Master of Science in Physics at Aachen University. And just to introduce you into our university, it has this RWTH in front of, which means in German Rheinisch-Westfälische Technische Hochschule, which means essentially it is a University of Technology. It has 44,000 students, with about 1/3 of them of foreign nationality. So it has a strong international part. It is one of the excellence universities in Germany. If you heard about that, it is in the QS ranking, it is rather high. And what is maybe also specific on our university, we have very many, as we have so many students, we also have many student initiatives where students can do research or other things beside of their course program. We are part of a European University Alliance. Here, it's called Enhance. We have other partner universities outside Europe, so you can also get in contact with other universities worldwide. And last not least, our graduates, we think, are highly valued by the employers. So what now about some short key facts about our physics department. We are about 40 professors with 1,500 students. We have large office and lab space. You see this building behind. It is a little outside the city center near the Dutch border, and I will come to the location of Aachen later. We have a broad research program in theory and experiment in this department, but we also have close connections to the Forschungszentrum Jülich, which is a large research center nearby Aachen. We have also collaboration with other faculties and with so-called Fraunhofer Institute of Laser Technology. And this all gives students a very broad opportunities to go along their interests to study projects or later their thesis. So from you can now imagine that I cannot present the research of 40 professors and more. So I will just give some brief examples and flash through them so that you can have a little image about what research is done at our university. First of all, we have a large group which is contributing to the research at the Large Hadron Collider at CERN. You all know probably this, that there is a big particle physics research center near Geneva. This is here, this air photograph below, and we are contributing to the so-called CMS experiment, which is called compact muon solenoids. You see here, this experiment is not really compact. Maybe you can hardly see this physicist who is looking into some of these electronics, so very large apparatus. Then we have another example is one from the field of astroparticle physics. Here, a group of Aachen is contributing to the so-called AMS experiment at the International Space Station, where they look for antimatter in the universe. Then there's a big condensed matter physics branch in our department, looking for new materials on the atomic level. One big project is the study of graphene or also phase change materials. Then there's a group working on nanoelectronics and the use in quantum technology. You want to have faster electronics, you want to make quantum computers, and all this is studied in these groups. As you all know, electronics has become smaller and smaller in the last decades, and now we are at the level of nanometers, and this is already in the region where atomic effects play a role, and we have to control these atomic effects or the atomic physics by using quantum mechanics, which you have learned in the bachelor, and finally maybe realizing it in a quantum computer. Yeah, then there's a new research field arising, artificial intelligence. And here also colleagues of mine are looking into this. There are some of them, especially from the theory institutes, they try to understand artificial intelligence using physical models, and others just use artificial intelligence for analyzing physics data, for example, in particle physics or in the design of new materials. Then there's an interdisciplinary field of biophysics where we have colleagues looking into the spectroscopy of proteins and also the imaging techniques like nuclear magnetic resonance tomography and positron electron tomography. They are also studied and improved with new instruments and new technologies. Yeah, and finally, there's the field of laser physics, which is also present on our campus. It is more located in this Fraunhofer Institute, which I have presented before, but there are also professors from physics working with the Fraunhofer Institute. and students have the opportunity, if they are interested in this field, to do their master thesis, for example. Here we study new lasers with higher power and short pulses, and also here everything goes to miniaturization. We also speak here about nano-optics and photonics, for example. So coming now to the program itself, we have here a program organized in 7 different study tracks. There's the first one, and these study tracks follow in principle the research fields which I have presented to you before. We have experimental particle physics, we have astroparticle physics and cosmology. We have quantum field theory, studying this physics on a theory level. We have experimental condensed matter physics, nanoelectronics, quantum technology, condensed matter theory. And from the winter semester 2026, so when you would maybe start in Aachen, we will have an 8th study track called Physics and Artificial Intelligence. Yeah, this is a short slide about the structure. We have a 2-year study time with 120 credits. And we have divided this in 4 parts, essentially. When you have chosen your study track, you will have 30 credits of compulsory courses in this track. And in addition, you can choose 30 credits from an elective part. So it's rather flexible. You have very much freedom which courses you want to take. And in the second year, the other 60 credits, you gain in a master's project. So the first half year is where you are introduced in the methods of the field, of the research field, where you will do your thesis. And in the last semester, you will then do your master thesis. Yeah, the career path is as follows. Yeah, you first had your bachelor program. And so we hope that you might join our master's program. And after our master's program, you have a lot of opportunities in the job market, in industry. But you could also think about continuing at our university with a PhD program. Currently, it is about half-half, that half of our master's graduates are continuing with a PhD and the other half is going to the job market. Yeah, after the PhD program, yeah, one has to see what comes then. Yeah, what are the admission requirements? First of all, you need a proficiency in English, of course. There are several language certificates which are required. We require, in addition, a graduate records examination, a GRE. You can either do the subject test in physics or the general test. For this, I have to say, this is only valid for the non-EU applicants. So EU applicants are, of course, treated the same way like our German bachelor graduates who apply. And we require an adequate qualification from your bachelor's degree. So we look into your module descriptions of, for example, courses like quantum mechanics, statistical physics, modern physics, and so on, and decide if you are qualified. Yeah, details on these requirements you will find on the webpage of our master's program. Link will be on the last slide. Yeah, and finally, a few words about Aachen, the town of Aachen. It has several names, not only a German name, it's also called Aix-la-Chapelle in French and Aquisgrán in Spain and Aachen in Dutch. So this comes from the fact that it is very, very European city, just located at the border of Germany to Belgium and the Netherlands. I have just put here some train hours distances to major cities so that you can see how far it is from us to the rest of Europe. And what is remarkably maybe is that you are from here, you are faster in Paris and London than in Berlin. Aachen has 260,000 inhabitants with about 60,000 students of them. So it's a student town and it's a historic city. And if you don't know, it was long, long ago, it was the capital of Germany, so to say. At least the kings were crowned here in Aachen. So thank you for your attention, and I'm happy to answer questions. And if you need further information, you can look onto this webpage, which you find here, where you find here the link. And on this webpage also this presentation is linked.
I'd like to give the mic to the second presentation or second program for today's webinar. This is a Master of Science Physics of the Earth and Atmosphere.
On behalf of 𝘱𝘢𝘪𝘥 and myself, 𝘱𝘢𝘪𝘥 is the study program coordinator of the master. I'd like to present to you the physics of the Earth and Atmosphere master at the University of Cologne, or short PEA. When you come to Cologne, you will be coming to a very thriving city in Europe. Some call it the heart of Europe, located directly at the Rhine River. Cologne is a very well-connected city concerning traffic, airports, and railways. It's one of Germany's largest cities with over 1 million people. It has a rich history dating back to the Roman Empire. You may probably know the famous cathedral, which was built or begun to be built in the 13th century. It's the home of many cultural activities, theater, music, art, and very specifically of the Kölner or the 𝘗𝘢𝘪𝘥𝘪𝘯𝘨, which you will then certainly experience. Cologne lives through its people, through it's a multicultural hub and very rich in tradition and diversity. The University of Cologne is located directly in more or less the center of Cologne. It's one of the oldest universities in Europe. You see here the main campus. It was founded in the 14th century. So many, many years ago, it has about 45,000 students. It's Germany's second largest universities. And thus we also cooperate tightly with other research associations, specifically in the region, for example, the Jülich Research Center or the University of Bonn. The Master of Physics of the Earth and the Atmosphere is situated in the Faculty of Mathematics and Natural Sciences. The faculty as such has about 200 professors and more than 60 study programs. The University of Cologne is very attentive towards international students. If you come from abroad, there's a wide variety of services that you can take advantage of. From the university, there's the International Office, which takes care or helps you with applications, enrollments, resident permits. It gives you information on networking events, cultural leisure activities, and also is offering a career service center. The International Students Association also gives you a lot of points of contact on cultural exchange and networking. The students give each other assistance and orientation with respect to, for example, finding housing or projects to reduce prejudice. Then also there's a lot of possibilities at the university to learn German. There are free German language courses and examinations connected to that. So 5,000 of the international students from all over the world are currently enrolled at the University of Cologne, and within our study program, we have about 30% of the students coming from abroad. Just some background information, what you would be expecting when you come to Cologne concerning financing and housing. So the semester fee is around 320 euros per term or per half year. There's generally no tuition fee. This semester fee includes a ticket for public transport, which is valid across Germany. The cost of living is on the order of 900 euros per month, but then you have to include also in this amount about 400 to 500 euros for rent. And some useful links here, which you can then click on if you look at the presentation afterwards concerning accommodation and other practical hints for coming to Cologne. If you're enthusiastic about the Earth system, so actually what is happening in our climate system, and also going further away from the atmosphere, maybe to the surface, into the Earth's interior, or then in the other direction onwards into the solar system. For example, considering space weather, you're exactly right with this study program on physics of the Earth and atmosphere. When you decide to study our master, you can choose between two areas of focus. One is geophysics, the other one is meteorology. Both areas of focus are strongly connected to the research which is happening in these two areas at our university. The application to our master's program is possible twice a year, once on July 15 and once on January 15 for the winter, respectively the summer term. The language of the program is English, so all courses are in English. The duration is 4 semesters, 4 terms, or correspondingly 2 years, corresponding to 100 credit points. A little bit on the curriculum that will be expecting you. So the first 2 terms here in red are the first year, where you will mainly be focusing on modules, compulsory modules, and elective modules. And in the second year, the third and the fourth term, your study work will be concentrating on preparing and actually carrying out the actual master thesis. The brown modules we see here, the prognostic and the inverse modeling, are common modules for geophysics and meteorology. In prognostic modeling, so in understanding the equations and learning the equations of motion and the dynamics, and also the magneto-hydrodynamics in the different systems we are wanting to understand and predict. And then in the inverse modeling, we are dealing with how to optimally use, for example, observations to reconstruct the Earth system in a suited way. Focus areas in meteorology include the compulsory modules, atmospheric dynamics and modeling, physical climatology, clouds and precipitation, atmospheric radiation, and atmospheric boundary layers. So the part of the atmosphere which is located in the lowest 1 to 2 kilometers, where basically all life takes part. The research in meteorology in Cologne is focusing on many things, but some of the things I would like to introduce here. So, for example, Arctic amplification. Why is the Arctic warming so fast? This is one major research focus at our institute, and a lot of the compulsory but also elective models that I will present in just a moment are actually also dealing with this research theme. Another research point is how can we prove predictions of extreme weather? We know that in the changing climate, we have more extreme weather that we are actually expecting. And of course, we also want to improve the predictions of these extreme weather events in a better way. And this is what we also teach and learn and perform research on. And the machine learning and artificial intelligence is also playing a more and more important role to exploit Earth observations, but also to better predict the weather situation within the next days or even weeks and months. Focus areas in geophysics are related to the compulsory models: geophysics of the solar system, space physics, direct current and electromagnetic exploration methods, and also there is an advanced geophysical field course, which you see some pictures of here. The research in Cologne is associated in geophysics very strongly to space physics of planets and moons. For example, the exploration of water on the moons of Jupiter is one very important aspect here, but also the exploration of the Earth underground, geophysical imaging and geomagnetism and hydrogeophysics are further research foci. Next to the compulsory models, we also have a variety of elective models you can choose from. For example, seismology, geomagnetism in space weather, or wave-based methods in hydrogeophysics. In meteorology, we have the polar meteorology as an elective model, machine learning in weather and climate research, energy meteorology, referring to renewable energy exploitation from wind and solar energy, advanced remote sensing, so focusing on novel satellite observations of the Earth system, for example, atmospheric chemistry dealing with air quality, and yeah, this one is doubled. So probably important today, that's why it's doubled. Earth system data processing is something that we also teach our students more and more. So how to deal with large amounts of Earth system data, which are becoming frequently available through model output, but also through observations, for example, from satellites. These are the models that we offer in Cologne, but actually our study course PEA strongly collaborates with a corresponding PEA course at the University of Bonn, where the students can actually also attend elective models in Bonn. Respectively, the students from Bonn can attend elective models in Cologne. So we have a strong collaboration here, and this increases then even the variety of models you can elect. In the third and fourth term, then you will be focusing on the master theme. So the first part of the third semester is typically then a literature review on a current research topic, giving you the opportunity to review what has been published in the literature concerning the way of your master thesis. Then we have a module called project work, where you have the opportunity to perform first measurements, data analysis, or look at simulations, perform simulations, and see if the methods you think of are actually feasible for answering the question you want to address in your master thesis. And then afterwards, in the last term, you will be working on the master thesis itself, carrying out research projects, learning to work scientifically and independently under supervision, but becoming more and more independent as you go. And then in the end, formulating a thesis of about 50 to 70 pages. Often you will then be connected within the master thesis to one of these larger research projects dealing with the themes I presented a moment ago. yeah, once you are done and presented your master thesis in a colloquium or defended the master thesis, you have a career prospects. This master degree in physics of the Earth and atmosphere provides you with skills to excel in a diverse range of professional areas. For example, all types of Earth system applications, as well as in the area of computational data sciences. It prepares you for a doctorate program within geophysics, meteorology, or geoscience disciplines, or qualifies you for leadership positions in specialized jobs, for example, at private public weather services, environmental agencies, renewable energy industry, geophysical exploration and consulting enterprises, scientific software enterprises, scientific and commercial aerospace institutions, and even management and consulting enterprises. The application, like I was saying, is possible for this study program twice a year, once in mid-January, January 15, once July 15 for the winter term, and January 15 for the summer term. The requirements you need to bring with you is a Bachelor of Science in the Natural Sciences of at least 100 ECTS points, or an equivalent degree program, but with the following achievements. You need to prove that you have successfully achieved 18 ECTS points in mathematics and 18 ECTS points in physics, in addition to at least 6 ECTS points in geosciences, atmospheric sciences, or astronomy. And in addition, we require that proof of proficiency in English, at least at B2 level. And please note that for international applicants, it's important that we have a two-stage process for application, first going through UniAssist and then through the University of Cologne. And we advise to start this procedure as early as possible. All necessary information you can find via this application webpage linked through this QR code. All further information for you we also collected in these dynamic links, which will be possible for you to access, or just go through the QR code here to the general page of our study program. And yes, I hope we could convince you, and we look forward to your application for the Master of Physics of the Earth and the Atmosphere, and greeting you soon here at the University of Cologne.
Presentation is from University of Stuttgart, Master of Science Physics program, presented by Dr. Patrick Rommel. Thank you.
A warm welcome also from me. I'm Patrick Rommel, and I'm the course director of the International Master's Program Physics at the University of Stuttgart. And today I will talk to you a little bit about what it's like to study here. So let me briefly begin by talking about Stuttgart. So Stuttgart is the capital of Baden-Württemberg, which is a state of Germany that is located in the southwest. So you can see here on the map, here's Stuttgart. So Stuttgart is relatively close to the border, not as close as Aachen, for example, but still it's not so far away from several other countries here. You can see we're quite close to France, to Switzerland, and to Austria. Stuttgart is very well known for its industry, especially for its automotive industry. But so you can see there's lots of opportunities for your career after you finish your master's program or your PhD. But there are also cultural highlights. So, for example, you can find here castles of the former kings of Württemberg. We have the 𝘱𝘢𝘪𝘥, which is a great combined zoological and botanical garden. There's the famous Stuttgart Opera and the Stuttgart Ballet. The University of Stuttgart has existed in one form or another since 1829. It's been renamed to the Universität Stuttgart or University of Stuttgart in 1967. There's a good 20,000 students enrolled at 10 different faculties. We have about 270 full professors, over 3,000 academic staff, and almost 2,000 non-academic staff, and cooperations with a large number of non-university research institutions that are quite close. There's also collaborative research centers and 2 clusters of excellence. The university also has quite an international profile. We have about 4,800 international students from more than 100 countries. We have dedicated centers like the International Center for Cultural and Technological Studies, several master's programs taught in English, tendency increasing, and more than 400 partner universities throughout the world. Good. Let me now come to the physics program in particular. So it is a 2-year full-time study program that is divided into 4 semesters. The courses are taught in English, so you don't need any German proficiency. English is exactly what you need. And we have 120 ECTS credits in total. Now, the program always starts in the winter semester, so your applications are also for the winter semester. It is an international program, so it also has a strong international profile. We have students from all over the world, from the US, from Latin America, from Africa, from Asia, India, China, and also from Europe itself. Typical batch sizes for us are 10 to 15 students, so it's small and cozy. So we can guarantee a great teacher-to-student ratio. And here I also give you the link to the study program website. The study program, of course, takes place at the Department of Physics. So let me give a bit of an overview here. The Department of Physics at the University of Stuttgart is dedicated both to fundamental research and also to application-oriented research. We have 15 research institutes with 19 professors. And here are some of the focal points of the research here. So we have solid-state physics. Actually, the focus on solid-state physics is also emphasized by cooperations with the Max Planck Institute for solid-state research that is quite closely adjacent to the campus. We have atomic and quantum optics, photonics, and very important here, quantum technology. In addition to these, there's also certain aspects of statistical physics, physics of soft and biological matter we have here, and then strongly correlated many-body systems and physics modeling and numerical simulation. So you can see an emphasis on quantum physics, quantum technology, solid-state physics. These are the topics that are researched here and where we have leading institutes. Yes, and as I mentioned, we have a close cooperation with other institutions nearby. I want to mention the Fraunhofer Institute and also the Max Planck Institutes, which are closely adjacent to the Vaihingen campus. Here, I give you an overview of the study program. So these are the 4 semesters, and they are essentially divided into 2 parts. So in the first year, you attend lectures, seminars, and lab courses. So we have certain compulsory lectures that everyone has to take, advanced experimental physics, advanced condensed matter physics, advanced quantum theory, very important. We have the laboratory, which goes over 1 year, where you do experiments and write reports. We have seminars where you hold scientific presentations and learn about certain topics in groups, presentations and discussions. And you have the opportunity to choose at least 2 electives. Here on these electives are closely related to the research fields that are prominent here. So I've listed, for example, here the options you could choose now in the academic year 25-26. This list varies slightly from year to year, depending on which courses are offered, but it's close to the same every year. So you can see quantum optics, advanced statistical physics, simulation methods, more solid-state theory, biophysics, quantum materials, quantum computing, quantum field theory, and so on. You can see the electives fit the research focus points I mentioned earlier. In the second part of your studies, this is basically the research part. You have 1 year for your master thesis research project. So these modules here are closely related to each other and basically allow you to be immersed into one of the research institutes for a whole year and participate in actual research. There are several options where you can do this. For example, at an institute of the university, or also certain research groups at the Max Planck Institute can also be chosen as the places where you do your thesis. Exactly, yeah. You can do it at the university or Max Planck Institute. You can do 1 full year theoretical or experimental research. And here there's a list of the eligible research groups. You can have a look when you get here this presentation. Right, as I mentioned, one prominent feature of the program is the close cooperation with the Max Planck Institutes. So nearby are the Max Planck Institute for Solid State Research, as well as the Max Planck Institute for Intelligent Systems. And especially during your master's thesis, students have the opportunity to join certain research groups also at the MPI. One thing I want to also emphasize here is the joint fellowship program with the IMPRS at the MPI, which gives which basically is a scholarship, and scholars get the opportunity to get involved with the MPI already before the master's thesis, attend certain seminars, and be involved in the research at the MPI already earlier, and they get a monthly stipend that covers the cost of living. There are more cooperations with other institutions, for example, on quantum technology. There is the IQST, a cooperation with the University of Ulm. There is the BMBF Future Cluster Quantum Sensors, so quantum technology, very important topic and very prominent here. And we also have the Center of Applied Quantum Research, which is quite a newly finished building, 2021, which is really a high-tech, high-precision laboratory specialized for the investigation and research of applied quantum technologies. There's cutting-edge research on developing, for example, quantum sensors for electric and magnetic fields and other applications here. And of course, if you join certain research groups here, you will have the opportunity to work in these laboratories. Now, one other feature I want to point out here is for international students especially is the Faculty Aid International team. So to help you be welcome at in our study program at the faculty and to help you find connections to your other co-students, we have a team of international students who get paid to help the others find their way with organizational issues, give out information, or just organize extracurricular events and activities. We've had city tours of Stuttgart, barbecues, meet and greets. We've visited the chocolate market in Tübingen in December, the pumpkin festival in Ludwigsburg, and now this year the medieval Christmas market in Esslingen. So lots of fun activities with your other students. And when you're a senior, you also get the chance of joining this team and get paid as a student assistant. Now, how does application and admission work? Briefly, I have here the admission requirements. So you need a Bachelor of Science in Physics is the straightforward variant, or it's also possible with a Bachelor of Science in a closely related field, though please note that there are certain mandatory requirements. So if your transcript doesn't cover mechanics, electrodynamics, or quantum mechanics, it's going to be difficult. You just have to have this prerequisite knowledge, otherwise it's difficult. Then we need an English proficiency certificate, usually a TOEFL or an IELTS, or a Cambridge certificate of proficiency in English, things like these. And of course, standard documents, higher education entrance qualification. I want to point out that the land of Baden-Württemberg, the state of Baden-Württemberg raises tuition fees. So per semester, it's 1,500 euros tuition fees for non-EU students. And additionally, there's the standard semester fee of currently 184 euros that every student has to pay. Certainly, for example, the IMPRS scholarship can help you with these costs. I listed some additional links and information on applications and so on. Yeah, the application period for the program is open now. The deadline for the next winter semester, so winter semester 26-27, is February 15th. Good. Yeah, I already mentioned the tuition fees. If you want to like get a sense of what your studies would cost, you should also assume something like a cost. The cost of living is usually like approximated here with these 990 euros per month. This is the same amount also that you need for a study visa to come to Germany. They demand a proof of funds it should be exactly this number or close to this number per month. And yes, we have the IMPRS Joint Fellowship Program. If you can get this will cover three semesters. And then for the final stage, there's also options. We have the STIBET 1 scholarship. And of course, you can take student assistant positions at the institutes, help in the lab, or tutor classes to help. Or you can do a little bit of jobbing on the side, though please note it's a full-time study program. You don't have time to like take on a big job. Here again, more information with this link. Yes, briefly about accommodations. So the program is located on the campus Vaihingen. You can see one view from the Department of Physics here. And here, by the way, there's like accommodation here in this area. So you can have accommodation very close to the campus within walking distance. There's more accommodation possibilities close by that can be conveniently reached via S-Bahn trains. Yes, more information here. And yes, that's it.
Now, the last but not least to present is University Jena, another Master of Science, Quantum Science Technology Study Program presented by Ramona Palmelli.
Hello from my side as well. My name is Ramona Palmelli, and I'm the coordinator of the Master Program Quantum Science and Technology. I will present you today the program and also like the academic environment which it is embedded. First of all, who are we and where are we? You can see here the Upper Center of Photonics, which is part of the Faculty of Physics and Astronomy at the Friedrich Schiller University in Jena, which you can see here. This is the main building. The university was founded in the 16th century. And Jena itself is, as we saw, located almost in the middle of Germany, we can say. And it's in the federal state of Thuringia, well known for its green forest and beautiful natural surroundings. The Upper Center of Photonics is a leading research center for optics, photonics, and quantum technologies. And in this exceptional research environment, we have the Upper School of Photonics, which offers 2 master degree programs. One is the Quantum Science and Technology, and the other one is the Master Program Photonics. The Photonics program has been running now for many years and is very well established with around 200 students currently enrolled. The Quantum Science and Technology program, on the other hand, is still quite new. Our second cohort of students started this October. That's why the number of students are quite small, but it's also good because it's really personal and everybody knows everybody. And many figures and data that you will see today are based on the Photonics program. But our clear goal is to grow the Quantum Science program to reach the same numbers in students as the Photonics program. I will show you now some reasons why you should choose Jena and the Upper School of Photonics. You can see here some pictures of Jena. It's a nice city embedded in valley and surrounded by green hills and nature. It is quite small compared to the other cities we saw today. It has around 110,000 people living in it, and from that are 16,000 students. So it is clearly a student city. And it offers many opportunities for sports, cultural activities, hiking, theater, and concerts. And it also has a long and deeply rooted tradition in the optical industry, like Carl Zeiss, Otto Schott, Ernst Abbe have been here and founded the world-famous companies. You can see here in a survey among physics students, our Department of Physics at the Friedrich Schiller University was ranked #1 for overall quality of education, academic support, study organization, and support for international students. Our master program is clearly international. As you can see here, over all the years, the enrolled students came from over 70 different countries, and around 95% of our master students are from outside of Germany. And many of our graduates remain in Germany after 5 or even 10 years after graduation to get a career in industry or academia. So I hope I gave you enough good reasons to come to Jena and to the Upper School of Photonics. And we take now a closer look to the program Quantum Science and Technology itself. So let's start with the application process. The application portal is currently open. And you can see here our different application deadlines. This depends on your country of origin. So, but I do strongly recommend to apply as soon as possible, so you will have enough time to get your visa arrangements done. And we only admit students for the winter semester. So the current application period is for the winter term 2026-27, which will start in October. Our admission requirements, you need to have a bachelor in physics, natural sciences, or engineering. You do not need to speak German, as our whole program is in English, but you have to provide us a sufficient English proficiency, at least level B2, and you can see here the list of tests that we accept and the minimum scores required. If you have not yet completed your bachelor's degree, you are still very welcome to apply now. So in this case, you just submit your transcript of records with the modules you have done so far, and you have to submit proof of graduation at the latest by the time of enrollment. After submission, the review process may take several weeks, and the final decision is made by the evaluation committee of the Upper School of Photonics. We do also have some scholarships. The Upper School of Photonics Master Scholarships are awarded based on academic excellence, are granted for 12 months. So it will cover your first year here and is currently around 990 euros. So this will cover your living expenses. And you can apply for the scholarships during the regular application process. You have to provide us 2 letters of recommendation for that. I will now tell you more about the program. So it is a 2-year master degree program taught all in English, and it covers multidisciplinary coverage in the field of quantum science. It is consists of different stages. In the first semester, you have the adjustment phase, where you have to choose 2 modules out of 5, depending on your previous academic background. So this is to close any gaps you might have. You can choose between advanced quantum theory, general relativity, introduction to quantum physics, physical chemistry, and fundamentals of modern optics. Then you have 1 essential module in the first semester, which is fundamental of quantum information. And you will have your first practical research training with the module Quantum Laboratory. This module gives you a hands-on experience, and you will perform quantum optical experiments or program quantum algorithms. So you will be in a lab setting and solve given tasks on quantum experimental setups. This module is either offered as a 4-week block in the semester break or for an 8-week during the semester. In the second semester, you will continue with quantum information, and you will already start to build specialized expertise by choosing from more than 25 elective modules. You can see them here. I will not go into the details of these modules. You can look this up at our homepage, where you have a description of each module, and you will continue the specialization throughout the 3rd semester. Now, what makes our master program special? It is close connection to research. As I mentioned in the beginning, the Upper Center of Photonics is a leading research center, and it works in close cooperation with non-university research institutes such as Fraunhofer or Leibniz Institute. And you can see here our 5 research areas, and I recommend to check them out at our website as well. And in this research environment, our master programs are embedded in, as I can say, because already in the 2nd semester, you will do an internship in one of the working groups. And the aim of this module is to give you a first-hand experience in a real research project. And you will carry this out under close supervision of a supervisor, academic supervisor. In the 3rd semester, you will start an extended research project. And in this project, you have to apply advanced methods and with a high degree of independence. And it is either theoretically or experimentally. And you can see here the amount of hours or working days that are required for these modules. And in the final and fourth semester, you will complete your studies with your master thesis. This entire semester is dedicated to your master thesis, and you will do it on a research topic that is relevant in the modern quantum research. And you will document your results in a master thesis and present it in a public defense. For all these three project phases, like the internship, the research project, and the master's thesis, it is up to you to find a working group where you can do it. So you can choose this according to your interests. And you can, as I said, already explore our website. You can see here some of the working groups for the quantum fields, and you can see what the groups are doing. If you're interested or have specific questions, feel free to contact the professors and ask your questions. So you can already see where you can go at the Upper School of Photonics. You can see here an exemplary 2-year study program. As I said, we start with an adjustment phase, and in the progress, you gain more and more freedom to choose according to your interests. And you can always get individual academic counseling to help select the modules that fit best your interests and your also your career interests, where you want to go. In addition to our study program, we offer some other extracurricular activities as well. One is the language courses for German. You can do one intensive German course right before the semester starts in September. It is for about 4 weeks. You can either join it here in Jena already or remotely. Then throughout the semesters, for each semester, you can also get a German course, and the Upper School of Photonics will cover the costs for these German language courses. Then we also offer some other extracurricular trainings like intercultural trainings, application workshops, writing courses, soft skill courses, and many others. And to connect you with the industry, already doing your study phase, and to strengthen your professional network, we regularly organize excursions to companies or to trade fairs. For example, this year we have been at the Laser World of Photonics in Munich, and in 2026 we plan to attend the Optatech in Frankfurt, which is an international trade fair for optical technologies, components, and systems. And here as well, the Upper School of Photonics cover the costs for these trips. And to prepare you for the study, before you come here, we offer two pre-courses in mathematics and physics, usually in September before the lecture period starts. And this is like to freshen up your skills in mathematics and physics. And it's also possible to attend it here in Jena or online. Then we also have a welcome party when the semester starts to welcome all our new students and to connect you with the students from the higher semester and with the professors as well. You have here some impressions from our this year welcome party in October. Beside the Upper School of Photonics, the Friedrich Schiller University itself offers some support for our international students, like we have an international office, master service center, a career service center, and many other things that help you to settle in Jena and to support you during your studies. We do also have a welcome buddy program. When you are a new international student, you are paired with a personal student buddy who supports you during your first days in Jena. Ideally, it is one from the same study program, and then he will show you around. You can ask questions and also make your first friend in Jena. Also, we have a really great university sport program with many options of sport activities each semester. This brings me to the end of my presentation. I want to highlight one last important point. At the Upper School of Photonics, you are, from the very beginning on, you get support through us. Me as a coordinator and the whole team of the Upper School of Photonics will support you from your application process until your graduation. So you always have like a dedicated contact person. And you can already contact us now if you have questions about the program itself or about the application program. You can see here our email address. And as soon as you get admission to the Upper School of Photonics, we will provide you information regarding student accommodation, visa applications, enrollment, etc. And we will help you through all these steps. And so, yeah, we want to make sure that you can come to Jena. So we are here to help. And yes, with that, I strongly encourage you to apply. And I am looking forward to your application. And yeah, don't forget, our first deadline is January 15.
Thank you very much, dear speakers, for staying until the end of the webinar and also for taking questions. Since others had also time to answer some of the questions in written, maybe I could start with a question directly to Ramona. I think it will be fair. The question was, can I start a research project with a faculty group in the first year itself?
Yes, because in the second semester you do the internship and then you do the research project in the third semester. But it is also possible to do this, the internship and the research project in the same group. So you can already, if you know you want to do your research project at a specific group, you can already do the internship there.
Maybe to follow up about the internship, does it should it be according, do you have any guidelines where the internship should be completed, or is it free? And does the university assist with finding one?
Yes, of course, we are here to help you. And I'm not sure now if I mentioned it, but you can do the internship at the university in the research group, but also like at the non-university institute or even in the industry. And of course, we are here to help if you struggle to find an internship. Was that the whole question, or was there more?
There are some more questions. I think it's about the background. Maybe you could also take that in the one in written. There was one question that I wanted to ask everybody. It was actually one of the first questions that came in about applying with us, like to do a second master. And I see Professor Roth already answered that it's not a problem to do a second master, but I know for some programs, they have either limitations, restrictions, or sometimes even you have to pay for that. If this is a case with your program, you could unmute yourself and elaborate on that, or maybe if anybody wants to elaborate on that. Then the silence shows me that there is not a problem. If you want to do a second master, then you can do a second master. Feel free to apply. Another general question was about high school grades. This was case of Varun, and I answered it for, like, Professor Roth already answered it, but I also listed the documents, and then I checked all other programs, and I didn't see high school grades as a requirement for any. I think it's not. Yes. No. Okay. Good. Somebody unmuted?
May I
Yeah.
step for the question of the second master? So as far as
Yes, of course.
there's a general rule that you cannot do a second master in the same topic on the same subject if you already hold one. You cannot do a second master in physics, for example. But you in a related field which is not too close, then it's possible.
So this is not true for us.
Okay.
We had people with a master in physics, so who did another master.
Mhm. So I can only speak for University of Cologne. There, it's
Yeah, maybe strange because it's the same state, but
All right, good. Thank you. That's why, yeah, thank you for the feedback. So please, dear applicant, I don't know if you're still here, but in case you wanted to also check the program from Cologne, in that case, it could be a bit different. All right, there were a number of questions about concrete background, and I think they were already very well answered, so I don't want to repeat them. The one point, all of you mentioned English, and then I tried to write all the time the English requirement as well as you also mentioned in your presentations. But the question still came, do you need German for lab work? Do you have German classes? I know Ramona mentioned just right now that it's either you can join remotely or in Jena for German classes. But for other speakers, do you have German classes as part of the program? Or maybe the language schools are available at the university. Whoever wants to take this one, please.
I can take that over for Cologne. So English is absolutely sufficient. You do not need any German to do our master course, but we offer German courses for free for the students who want to learn German. They are welcome to learn it, and they can learn it for free.
Thank you. Maybe feedback from Stuttgart. You are muted. Patrick, if you hear us, you are muted.
Can you briefly repeat the question? I
Yeah.
was just answering one of the chat questions.
Yeah, of course. Thank you. So the question was, the program is full in English, and
Yes.
but at the same time, is anybody expected to have German for lab work? And generally, do you have German courses as part of the curriculum, or do you have maybe
Okay.
language school?
So there are several possibilities to do German courses. For example, before the study program, there is an intensive German course, so you can learn German here, but it's not needed at all. You can go through the entire curriculum only with English, and also in the institutes, there is no need to talk German to other institute members. It's completely standard that everyone can speak English. Now, that said, the electives are also in English. Sometimes, if for example, there's also the German physics course. If there's so sometimes they are somehow shared, and the course might be offered in German if there are no international students in the course. And sometimes some things there might be some courses in German, but this is a very minor point. You don't need any German.
But still encouraged to practice some when you are already in German.
Yes, of course.
Probably this will be the advice you get when you arrive, because with the bureaucracy and all of that, you will face it. All right, thank you. Maybe one last question. I know there were so many questions, but I want to combine two questions, and this will be for all speakers. Doesn't matter if you already took that one in Q&A or not. So the point was about internationals coming, especially from non-EU countries. How did you observe? Was the transition difficult for them or not? Are they lost or not? And the second one is, as a prerequisite, is it to have a thesis on the bachelor's? Because I saw the question, if I didn't do thesis in my bachelor, is it a problem? And I think it was feedback from Cologne that it's requirement to have a thesis on your bachelor's, but in some countries it's not always like this. So could you please, in case you had such a case, elaborate on that? I don't know. I don't want to. Yeah, if anybody already has a feedback on that, please unmute yourself.
Maybe to the
yeah.
first question. So because our study program is very small considering the number of students, so we have a very good a quote in people advising and studying. So in the master courses, we have typically 10 people that are then part of our elective and compulsory modules. So maybe on average, and this leads to the fact that the students among themselves are also very tightly connected. And the international students that come new to our study program are very quickly integrated. I observe that very frequently. The working groups form where they solve problems, programming problems or other type of experimental problems quickly together. And yeah, they quickly normally come together and make life for the new students very much easy in that respect. That's what I observe, and I seldomly see that the people from abroad are actually not part of the course dynamics.
Mm-hmm. Thank you. Professor Roth, if you have any feedback for that.
So actually, I have I can't remember that we rejected somebody with who had no thesis, but maybe we also didn't have one. I'm now not sure, or if we just missed it. I think we could one could arrange something that the thesis could maybe be retaken in some special way. It would have to be discussed on the individual basis if something has to be. So if the candidate is really promising and well qualified, and only the thesis is missing, I think one could find a solution. What concerns the onboarding, we have special programs on supporting the international students when they come to Aachen. There's first the general program of the international office of RWTH Aachen. They also have hints and tips how to find accommodation and so on, but essentially people have to do it, of course, on their own, which is probably in every university city not so easy. But up to now, yeah, students managed to find it. And what concerns integration in the physics department, I also can just repeat what was said, that the courses are small. Yeah, in the master, they are typically maybe 20 people, 30 people, and often also courses with much smaller numbers. And there is usually no problem to find contacts and to be included in the study program or in the community of the students of the study program.
Mm-hmm. Thank you. Maybe now let's ask Jena, Ramona, if you had cases of applicants without bachelor thesis, and then
I can't think now of an example if we had this, but I would say if it is a valid bachelor degree, then we can accept it. I mean, if the bachelor degree this didn't include a thesis, so it should be okay for us. But as Professor Roth said, it's always like should be looked into individually. But I think it should be okay as long as it's a valid bachelor degree. And for the second question, we have many opportunities in the beginning and throughout the studies to connect everybody with the current students and also with students from like the photonic program or the physics program. And we have a lot of social activities that we organize, such like a Christmas party for this week we had, or then like the trade fairs we visit, where it is always a great chance to connect to each other. And yeah, but in the end, it's up to everybody itself what they are making out of it. And we are aware of the fact that it is it can be hard to get abroad, to be away from your family and everything. But that's why we are also here, like me as a coordinator, and my colleague is coordinator for the photonics program. So we are here to support, even in the cases when you get homesick and everything.
Mm-hmm. Thank you. And Patrick.
Yes, so bachelor degrees without thesis, I'm also not aware at the moment of any concrete cases like this. So if with that is meant a bachelor degree that does not contain a thesis at all, I can only say the same. I assume if it is a valid bachelor degree that is internationally recognized, then that should be possible. If the question was meant in the sense of if you haven't finished it yet when you apply, that is not a problem. It's a quite typical situation given the application deadlines and so on, that you are not yet finished when you apply if you just like follow up immediately. Okay, and the other question was about how difficult it is, or how we help with like adjusting to the university. Yes, during the application phase, you can ask questions and get help from me or from the Department of Applications after. And then in the preparation of your arrival, I will keep you informed of what things you need to do, visa, housing, and so on. And there's also the international office, which offers great information on all issues that international students face in all phases. So both before the arrival, around the arrival, but also after you are here. And then additionally, I mentioned the international team and also other senior students who can help you. In my experience, that you they are very helpful, and you will be able to adjust to your new situation here very well.
Good. Thank you. Yeah, please always check international offices. And another hint would be to start to connecting with the current students, maybe to check them on LinkedIn and then connect and ask, and maybe already have somebody to see when you come to the study program. So thank you very much. First of all, apologies, dear panelists, for taking 15 more minutes of your time. We appreciate that. And yeah, sorry for this, and thank you as well. Dear attendees, I hope and I think that the webinar was very informative to everybody who attended. For the ones who missed it, you are you still will receive a recap email, and maybe we'll see the webinar recording later on. I don't know. With this, then, thanks once again. Best of luck with applications. Please keep an eye on deadlines. Make sure you have all the documents ready. If you have questions, check the program pages, and only then contact the people. Yeah, I think this will be it. This is the last webinar of this year. Yeah, Happy New Year in advance. Have a great start to 2026. Thank you very much. Bye.
Thank you.
Bye-bye. Thank you.
Bye.